what you would do is, you would have as a criteria in your design specification to them, is it must include at least 4 triangles, two sets of which are different sizes, and you must have a demonstrate to me as the client that they are in fact exactly the same size, that they are congruent. And you've got to demonstrate the working to show that they are. So I won't accept your design unless you do. That sort of thing. So, you could do it that way. So you could get that far. The next one is probability. Can I do probability on this?
Probably.
You can have different kinds of coffee and the probability of which one's ordered by whom.
Yep.
I was going to say human error, mistakes.
Yep.
Yeah.
All of that sort of stuff. Yeah. So if you gather some data and get some experimental results, you can turn that into a probability. Like if 25% of the people order long blacks, what's the probability that the next person who walks in is going to order a long black? The answer is 25%, 0.25. Assuming though, then you can talk about assuming though that the sample upon which I generated my 25% out of the experiment wasn't based on 10 people. Because the idea that the larger the data set that you're working from, the more reliable is the probabilities that generate. That sort of thing. So you could do that. Sum and product of results. If I have 4 people come in, what's the probability that they will all order a long black?
1/16.
What's the probability that one will order a long black and the other 3 will order something flat white? Probability for long black is 0.25, probability for flat white is 0.3. What's the probability one will order a long black and the other 3 will order a flat white? Whatever.
Yeah.
But it's basically looking at how you're combining probabilities. Do I add them? Do I multiply them? Those sorts of things. If I have a person come in 4 times, what's the probability that the person will order a long black every time?
That's a hard one because people have preferences.
Thank you. Very good. And then you can start getting into the difference between random events and events which are not random, where probability is not quite so. The idea of independence of events in probability? That's how you get into that.
You could also make it very alive with it, because you could go, okay, this is my sample as the class, okay, what would you order,
Yep.
sort of thing, and then maybe as a random get 4 students from other classes or the principal.
And generate a probability set based upon the evidence and get some people to actually come in and see if the probability, the evidence we've got is actually supports what happens in the future. Yeah, all that sort of stuff. So do you get the idea that the context that you operate in provides the framework for the mathematics, as opposed to what most mathematics has been traditionally is you do the mathematics and use it to explain something else. You start in the real world with a real world problem and a real world question, and it's that question and their quest to solve that which is where they learn the mathematics. Now, does this mean you don't direct teach? No, it doesn't mean that at all. Because take this for argument's sake, if you pose a question, all right, what's the probability that the next 5 people that come in will order a long black? And they will sit, they've never heard this sort of idea before, they look at you and go, haven't got a clue. How might you do it? And then you just get up the front and you go, okay folks, this is the way it works. When you have these sorts of situations, this is the thinking that goes into it, this is the mathematics, and you teach the lesson. But you're teaching it within the context of a real world situation they're familiar with, that they understand well. You've got all of that relating knowledge that you've built up around it, and they're understanding this new idea within that framework. They're not understanding it as this separate individual thing that they've got to learn. So you're teaching at the relational level as opposed to the multi-structural level. That makes sense? Good. So, what I would do, my goal, if I was doing this, would be, I would look at my year 11-12 program. I would try to have about a half a dozen of these types of situations of real-world contexts that I could operate within, each one running for a substantial period of time. You're not going to get one that satisfies everything. Because once you get down a bit further, like this one works because we're operating at a fairly low level mathematically. If I go down a little bit further, angles of trigonometry, angles of elevation and all that sort of stuff. Give me a context that you can use in school, that you could run for a few weeks, maybe even a couple of months, that you could put all of this sort of thing in. And you could even get in like linear functions, all this sort of stuff. What could you do?
Could you design a building?
You could. What you do is you get them to be, you're the customer, they're the architect, and you give them a set of, I want a building, but it's a very special building.
Yeah.
And you set them a list of criteria on the building which forces them to do something like this. I want a roof line that looks like this. All right? And then, so what they would have to do is they have to model the roof line. And what I would do is when they give me, like if that's the edge of the roof, and it goes to there, that's when they give me the first one, and the function that they have used is something simple like y equals sine x, or whatever. What I would do is then say to them, no, I don't like that roof line. What I want it to look like, and you know how you have y equals ax plus, a sine bx plus c plus d, and changing each of the values of these does something to the function. It moves it right, moves it up and down, all that sort of junk. What I would do is say, no, I don't like that one. I want it to do this. I kind of like the shape, but I want it to go, rather than doing that, I want it to do it twice as often. And I want the whole thing, I don't want it starting there, I want it starting there. You know, that sort of thing. So then what they have to do is look at their function that they've used to generate their roof and modify it using the principles of how that works.
Could you have them build a dollhouse?
You could, and the actual building of the thing is good if you can do it and you've got time. Because otherwise it's just all theory on a board. The more physical that you can make it, the better off you are. That makes sense? Now, when you look at these things, look at the way, see how they're presented in an order? Do you have to do it in that order? No, you don't. All right? When you're operating this way, when you're operating within context, you address this. Generally speaking, they go from harder concepts, easier to harder concepts. But when you're operating like this, you address things as it suits the context that you're working within. If you want to do something from later on down the syllabus, even from another number, you do it. Because you might be able to get two aspects of 2 or 3 different things, all done within the same context. Happy with that? Good. Any questions at this point? Good. What else do you want to know about the syllabus? We should yeah.
Just the E, that's an extension, or there's a square, then there's an E.
Yeah.
So that,
the way, if you go back to the start,
yeah.
Remember you have Unit 1, the extension doesn't happen until the end. This syllabus, go right to the top of the syllabus. The answers to questions like this are usually contained within the document.
Yep.
It's a unit, it's a 2-3 unit syllabus, so it's the same syllabus applied to 2 different courses. So the stuff that has no identifier on it as being something different, it would be a part of the
3 unit.
And then, no, it doesn't tell you that it's extra.
Yeah, 2 unit.
It's the 2 unit, it's the common stuff.
Yeah.
The extra stuff, which is the 3 unit, it will have an identifier on it to tell you that. They all work that way. the New South Wales syllabuses. So the E stuff would be done as part of the 3 unit. Does that mean you can't do it as part of the 2 unit?
No.
No, of course not. If you happen to get to it and the kids are up to it, go artists. Does that make sense? Good. Good. Now, a couple of things. Let's have a look at the section in the syllabus that basically says, thou shalt. That's all just the stuff. Let's go into this bit. Have a quick read of what it says about the 2 and 3 unit course. If a kid comes to you in halfway through year 10, this happens regularly, can I do the 2 unit course in maths next year? How do you know the answer to that question?
By reading that.
The syllabus tells you so. It says the content and depth of treatment of the course is intended for students who have completed the school certificate mathematics course and demonstrated general competence in that course. So if they're not in that course and passing it, the answer to the question is
No.
probably no. You're going to have to try and talk to the head of department and see what you can swing. 2 units is intended to give an understanding, and it's about, notice how it says applicable to the real world. Does that sort of give justification? If you do what I'm suggesting, does that give justification for it?
Yeah.
If you stay on a pad and a pencil and just work out of the syllabus, is that real world mathematics?
No.
No, it's pad and pencil mathematics. It's content and theory. It's not applied to the real world. Okay. What it says... Okay. So it also says it's a minor discipline at tertiary level. So if someone wanted to be an engineer, should they do 2 or 3 unit maths? They should do 3. Now the 3 unit one says... Yep. So it says the content of the 3 unit includes the whole of the 2 unit, and its depth of treatment is specified in Part A and Part B. It's intended for students who have demonstrated mastery. So if someone was saying to you, I want to do 3 unit mathematics, what would you expect them to be getting in year 10?
80s.
80s. So once you get down into the 70s, it's starting to drop a bit low, unless, of course, they just sat in their bum for the last 3 years and haven't done it. Alrighty? No, it is recommended as the minimum basis for further studies in mathematics as a major discipline. Mathematics and the support of the physical engineering sciences. And it also says, although the 3 unit course is sufficient, it's recommended that students actually do the extension, the 4 unit course. One of the things that's confusing about the New South Wales syllabuses is it uses the words extension and 2 unit, 3 unit, 4 unit, and it's a bit, they mix them up a bit.
Studies.
Yeah, it's a bit hard to know which one they're talking about. But most people who do the mathematics, the kids and the teachers, talk in terms of 2 unit, 3 unit, 4 unit.
What's studies then? Like maths and then studies?
It's like general mathematics.
Yeah, and then there's studies, or there was.
They all just lower levels of
So it
maths.
doesn't actually count as a unit, it's like 1 unit.
I'm not sure what the
No
actual
units.
are. I don't know.
So does everybody have to do the 2 units? Because I don't see 1 unit anywhere.
No, that's
It's
different, no.
different syllabus
So
anyway.
that's
If you
goes
go
down.
right back to the start,
Sorry. That's K to 10, this is 11 to 12.
12.
come back